Let's talk about our observations about energy. We have the question, how can we test undirected macroevolution? We're going to present an equation again, a very simple equation, where we start with dead chemicals, we add information, and we'll talk about that in the next module. We need to add energy, and we add structure, as well as other stuff. And the result of that is a living cell. Now, the cell is the unit of life. The transition from dead chemicals to a living cell is very complex. It's never been shown to be done in a lab, but it's the first step. Again, if you go to module 2, you see that evolution can't get started. Well, evolution can't get started if there is no first living cell. So the cell is the unit of life. It is the reproducing, self-maintaining basic unit. Here's a statement about the cell and basically about everything. It needs to continuously replenish its energy. So we're going to focus on the energy part here. What we observe about energy is that things naturally move from a high energy state to a low energy state. For example, a rock rolls downhill. Well, if a rock is at the top of the hill, it has more potential energy than when it's at the bottom. So it moves from a high potential energy to low potential energy state. Everybody who drinks coffee notices that their coffee will grow cold. And that's that's moving from a high kinetic energy state to a low kinetic energy state. We never see the reverse of this thermodynamic natural law. You never see a rock rolling uphill by itself. I never experienced my cold coffee being warmed by a colder room. There are no exceptions to this common experience. Now, I want to bring up a nit here, is that somebody would say, well, it's theoretically possible that this could happen. Yeah, it's theoretically possible that a unicorn could self-assemble in my room by all of the carbon molecules arranging themselves in a particular way. The theory is, as we'll see when we talk about how we should understand this, is that theory is not the point here. The point is what happens in reality. And the reality is there are no exceptions to this common experience. So what we observe is we have life represented by the flowers in the picture. And when we take away the energy from that life, we wind up with dead chemicals. The point here is that cells need energy to stay alive. And that's why we eat food, which is a form of chemical energy. So chemicals and energy are required for life. This is not a sufficient condition, but a necessary condition. What I mean by that is if you take a bunch of chemicals and you just inject some radiation into it, you're not going to have poof, life. But you need energy to be able to create life. The observation we want to make here is that living things have more energy than dead things. There's additional energy that those chemicals have in cellular life than when they're just randomly dispersed through the environment. Again, there are no exceptions to this common experience.